Today, Rajsekhar sir asked me to shift my class. So, for the sake of him, instead of 9:30, I am taking at this time. Let me start today's class. In this class, I am going to conclude the last but one concept of your control system. After this, only one last concept is left over, that is the concept of controllability and observability. Anyhow, let me continue. Let me continue this class with this first problem of this class. And remember, all of you, in the previous class, I have just started the solution of the second concept, solution of state model. So what is the solution of state model means? What is state model means? It is equal to x dot is equal to, all of you aware, ax plus bu. So the solution of this state model can be obtained as this is x dot. So we will apply Laplace transformation. Then you will get s into x of s. Okay. After this, we applied inverse Laplace transformation. Then you are going to get the terms in of what? X of t. So this x of t is known as what? Solution of state equation. This is known as what? Solution of state equation. Okay. Now, small, very simple derivative. How to get x of t means just simply apply Laplace and then inverse Laplace transformation. Then you will be getting the formula for x of t. So this x of t solution consists of the sum of 0 input response plus 0 state response. So what is 0 input response means? It is the transition matrix multiply state transition matrix multiplied by x of 0 plus one formula for 0 state response I have given. Once again, what is state transition matrix means? All of you are aware that this is equal to L inverse of Si minus A, Si minus A whole inverse. L inverse of Si minus A whole inverse. Okay. Now, obtain the time response of the. Now here I am jumping to your first without wasting the time. I am just jumping to the first problem. So in this concept, the problems will look like this. So he is asking you that you observe the question. Obtain the time response for the system x dot is equal to a into x he has given. That is, he has given a is equal to this one, and the initial conditions he has given as one a row matrix. And observe here he has given a transpose. He has given a transpose. Transpose means you will get x of 0 will be equal to what? A column matrix 1 1. So from this one we will try to solve this part. We will try to find out what x of t. X of t. Now how to find out the x of t means, just simply let me take a blank page for this first problem. Let me take a blank page for this particular first problem. So solution here is given data. here he has asked you to find out x of t for the given state model. So this is known as what? Time response. Means the variable with respect to time. So he is asking you the time response x of t. Given data is so he has given the data as a is equal to 0, 1, minus 2 and then 0. And he also he has given b, he has not given b covered d, the b will be equal to what? 0. And similarly, once again he has given x of 0 transpose. So I am writing directly in terms of this one. So it will become a column matrix 1, 1. Now, mathematically, to solve this one, I am just writing the formula. Mathematically, x of t is equal to e power at. Mathematically, x of t is equal to e power at into x of 0 plus integration of 0 to t e power a into t minus tau into b into u of tau. Remember, the integration is with respect to tau, not t. So this is the formula you need to remember. This is the generalized formula for, there is no derivation according to your syllabus. Just here you need your memory to remember these things. So mathematically x of t is equal to e power at into x of 0 plus e power at into something b into this one. Now if you observe in the given data, he has given the value of b is equal to, what? 0. 0 means the integration term will become 0. Hence, you will get the reduced formula in this particular problem is equal to e power at into only x of 0. So first you need to find out e power at. What is e power at? E power at is once again L inverse of S I minus a whole inverse. Si minus a whole inverse. So L inverse of Si minus a whole inverse అనేది మనకు వస్తుంది. So Si minus a whole inverse means once again, rather than directly you can't apply inverse Laplace. Hence we need to come from inside. Inside means first you need to find out what Si minus a will be your first step to solve this problem. So what is S? S is S0 identity matrix multiplication. You will get Si is this one minus a is 0, 1, minus 2, 0. So if you subtract these things, then you will be you are going to get here as one is S minus 1 and then 2 and then S. Now next is you need to find out its inverse. You have to find out its Si minus a whole inverse. So that is mathematically equal to adjoint by determinant. Now if you do that adjoint by determinant, so what you are going to get here? So adjoint of that particular matrix is, if you do simple mathematics here, then you will get adjoint as S minus 1 is plus 1, 2 is minus 2, and this is S. And about determinant, it is equal to 1 divided by, if you cross multiply these two, you will get S square plus 2 is the determinant value. Now if you send this into a inner side, then I am just moving to the next page. If you just add this to inner side, then you are going to get here as Si minus a. Finally, you are going to get Si minus a whole inverse is equal to, if you send the denominator part into the matrix, you will get S divided by S square plus 2, and this one 1 divided by S square plus 2, and this one minus 2 divided by S square plus 2, and this one s divided by s square plus 2. Now next is you need to apply what? You need to apply inverse Laplace. So this is about this one. Now you to get that one, you need to apply inverse Laplace transformation of Si minus A whole inverse is equal to Si minus A whole inverse is equal to, so L inverse of S by S square plus 2. L inverse of S by S square plus 2. So L inverse of S by S square plus 2 ante you are having one formula S by S square plus some B square. So I can assume the B as root 2. I can assume the B as what? Root 2. Then the formula for that particular one will be cos of dt, that is root 2 into t. And for this one, 1 by root 2 into sine of root 2 into t. And for this one, minus 2 by root 2 into, once again, sine of root 2 into t. And for this one, once again, simply cos of root 2 into t. So now, what is x of t? X of t is mathematically equal to, x of t is mathematically L inverse of Si minus A whole inverse into x of 0. It means that you need to multiply this matrix with what is x of 0? X of 0 is 1 1. Now if you observe, this is 2 by 2 and this is 2 by 1. So the resultant matrix will be 2 by 1. That will gives you the directly x of t. So x of t will be equal to, if you add those two things, then you will get a single column matrix with 2 rows, which is equal to, so cos of, if you multiply this matrix with this 1 1 column matrix, then you will get cos of root 2 into t plus sine root 2 into t divided by root 2. And next, minus 2 by root 2 into sine of root 2 into t plus cos of root 2 into t. Root 2 into is the answer. Is the answer for what? X of t. So for the given state model, this is your x of t. All the terms in terms of x. So it means that it is a two row matrix, means if you split right in terms of equations, you will get here as x1, the first variable with respect to time, as cos of root 2t plus sine root 2t divided by root 2. And similarly, another second variable is x2 of, there are 2 by 2 matrix means 2 variables untai, minus 2 by root 2 into into sine root 2t plus cos root 2 into t. Kind of root 2 into cos. So this is your in terms of equations representation of your time response. So here this is your time response. Time response. The overall conclusion of this problem is, he will be giving you a question like this. He will be giving you the data as a, b, and x of 0. So based upon the given values, you need to just substitute those values in this particular formula. Okay. So substitute and then individually ఒకేసారి add multiplication చేయరు కాబట్టి individual terms తీసుకొని you need to say take the separate గా addition and multiplication చేసుకుంటే last కి you will get x of t. So this x of t is known as what? So this x of t is known as a your time response. This x of t is known as what? Your time response. So like this, simply addition and multiplication of matrices with inverse of the given matrix. So first step is you write the formula, and then based upon the given data you need to first find out e power at. So after finding the e power at, multiply with this x of 0. In this particular problem you got the final answer. You got the final. If you are having any doubt, be feel free here to ask. Okay, now next is, so the same thing problem I have given in the notes in your notes. You just refer those notes. We got the same answer what I just solved here. Now the last problem under this concept, the last problem under this concept. Observe here. So he has given x1 x12 dot and also x of 0. Now he has asked you to find the time response. Find the time response for unit step input. Find the time response for unit step input. Unit step input. It means that he has given u of t is equal to 1 unit step. So let me solve the last problem here. Then which ends your the last but one concept. Then in the next class directly we will go for last concept, controllability and observability. So let me solve this problem. In the same lines what I have solved here. So here the question is, so if you are having notes, you just refer. Otherwise I will write once again here. Here the question is, x1 dot x2 dot is equal to, so he has given one matrix 1 0 1 1, x1 x2 x1 x2 plus 1 1 u. So and also he has given x of 0 of transpose is equal to 1 0. Now he has asked you to find out, this is the question. Now he asks you to find time response find the time response for unit step input for unit step input. So solution here is the given data. While solving the problems, any subject, you need to write first the given data. So the given data here is A is equal to 1 0 1 1. Next B he has given as 1 1. Next x of 0 will be equal to once again a column matrix 1 0. Transpose this step. And also he has given input u of tau is equal to u of t is equal to unit step kabatti 1. That is the given data. Now, mathematically, time response. Mathematical time response is given by formula x of t is equal to e power at into x of 0 plus integration 0 to t e power a into t minus tau into b into u of t. Now in this problem, as he has given defined there is finite values of b and u of t, hence you need to consider this formula. Now what is e power at? Once again I can write e power at is L inverse of Si minus A whole inverse. So further, if you observe here, this e power at can also be written as e power a into t into e power minus a into tau. E power minus a into tau. Separate ga chesi kuda rayochu. Separate ga chesi rastunna tarvata what we can observe here is so this e power at as we are integrating with respect to tau, okay, hence the t can be treated as constant term, so we can take it out from the integration. If you take it out from the integration, the t, then directly for the sake of reducing the number of steps sum, I can write e power, the formula I can write here, e power at into multiplied by x of 0 plus integration of 0 to t e power minus a into tau into b into u of tau into d of tau. And simply I can assume here, if you find out e power at, if you found e power at, then automatically you can able to just replace t by tau, then you will get e power minus a tau on replacing t with minus tau vachina value. And in this problem, once if you find out e power at, then x of 0 ఇచ్చినాడు, e power at find out చేస్తే automatically e power minus a tau కూడా find out చేసినట్టు, b already ఇచ్చినాడు, u of tau he has given 1. So simply first if I can able to find out e power at value, then directly multiply the obtain e power at value with this expression, Okay, now first step, I need to go for here as e power at. What is e power at? Once again, formula for e power at is L inverse of Si minus a whole inverse. So what about Si minus a? So Si minus a can be written as, so S is S 0 0 S and minus a. So he has given in the given question a as 1 0 1 1. So if you do simple mathematics, you will get simple mathematical subtraction. So you are going to get the Si minus a is S minus 1 0 0 and then minus 1 and then S minus 1 in this S minus 1. Now if you find out the inverse of that particular one, so Si minus a whole inverse can be written as adjoint by determinant. So if you do simple mathematics, then you will get this matrix as, this is already S minus 1 and this will become 0 and this minus 1 will become plus 1 and here this is once again S minus 1 and determinant is, if you cross multiply all those things, you will get S minus 1 whole square. Now if you send that one to the inner side, then you will get here as Si minus a whole inverse is equal to, if you send to the inner side, then you will get here in the already S minus 1 only, 1 S minus 1, 1 S minus 1 will get cancelled and here 0 and here 1 divided by S minus 1 whole square and here 1 divided by S minus 1. Now, so next is you need to apply L inverse of Si inverse Laplace transformation for this given expression. Then you are going to get what? E power at. Then e power at is equal to so all of you aware that the formula for 1 by S minus a is e power at. So the same thing I am applying here. So hence here it will become e power t 0 and for this one t into e power t and for this one e power t. You got this expression for this one, and similar for e power at, then for e power minus tau, so the matrix will becomes t replaced to minus tau, e power minus tau 0 minus tau into e power minus tau and e power minus tau. Now you got e power t and e power minus tau also. Now in the given formula, you just first step is you just multiply these two, and then after that one integrate that value and substitute these limits, and after that add with x of 0 and then finally you multiply those two matrices. So hence if you do that simple mathematics, let me take a new so let me write here. Then finally you will get, I am writing expressions, x of t is equal to what you will get formula I am rasna. Once again I am going to write the formula here. What I derived is e power at into x of 0 plus integration of 0 to t e power minus a into tau into d into u of tau into differentiation of tau is the formula. What you got e power at So you got e power at as e power t 0 t into e power t into what is x of 0 1 0 plus integration of 0 to t, and once again e power minus tau 0 minus tau into e power minus tau e power minus tau into what is b has given 1 1 into 1 into differentiation of this one. So further, if you multiply these two, it is same plus integration of 0 to t. If you multiply those two, then you will get a single matrix. You have e power minus tau, and then here this one will be getting, you are going to get here as e power minus tau into 1 minus tau. Now apply integration for this one. To apply integration for that particular one and do simple mathematics. You apply integration, then you will get here, this is same, you will get here as, after substituting the limits, 1 minus e power minus t into e power t into e power minus t. Now add that value with 1 and 0. Add that value with 1 and 0. Then this will become 2 minus e power minus t, and then t into e power minus t multiplied by e power t 0 t into e power t. Finally, if you multiply these two, you will get the final answer. So in this problem, if you multiply those two, you will get the final answer as x of t is equal to, x of t is the matrix, is equal to e power t into 2 minus e power minus t, and one more is 2 t e power t. Multiply those two things. This is your final answer. That is your final answer. So like this, you can able to solve the problem. So this is known as what? The problems on time response. Time response. The time response analysis. The time response analysis. Okay. If you're having any doubts, you be feel free here to ask. So here is the end of this last concept. That is the concept of what? There is the concept of determination of time response analysis. Yeah. This one. So if you are having any doubt, be feel free here to ask. So here is the end of my this concept and today's class. So overall conclusion I am giving here. So we discussed in a single concept that is the solution of state matrix. So this in this particular one solution of in this particular one e power at is known as what state transition matrix, and the solution of state transition is x of t is equal to e power at into x of 0 plus integration of 0 to t e power a into t minus tau into b into u of tau into d of tau. So from the given data just అన్ని multiply చేసి add చేస్తే you will get the final answer as x of t, that is time response analysis. So here is the end of this concept. So in the next class one last concept is there, that is the concept of controllability and observability. So which will conclude your unit 5 of the complete control systems. Complete control system. So that I am going to discuss today. I am going to discuss in the next class. I am giving you 2 minutes of time. If you are having any doubts, you can unmute and talk. Any doubts, be feel free to ask them. So tomorrow I am not going to take the class. Tomorrow I am having some work. So in the next class, directly I will be continuing in the next week. Only one class is required. Don't worry. With to conclude this syllabus. So here is the end of my class, and here is the end of this last but one concept. So in the next class, in fresh, we will go ahead with the last concept, that is the concept of controllability and observability. Here is the end of my class. You can log out. My class is over. You can log out. The class is over, you can log out.